Welcome to video 1 of a 4-part video series concerning the National Water Model Learning Module found on Hyrolearn.org. My name is Easton Perkins. I am a student at Brigham Young University and a research assistant in the Hydroinformatics Research Lab. This video will be going over exercise number 1 found in the National Water Model Notebook number 2 titled Mapping and Xarray. To access the National Water Model, search Hyrolearn.org. This will take you to the main page of Hyrolearn.org where you will type in the National Water Model and click on the icon here to access the page. Once you have navigated to this point, you should be on a page similar to this one. Welcome to the National Water Model Learning Module here on Hyrolearn.org. Here, you can be provided with an introduction to the National Water Model, a brief overview of the history of the National Water Model, why experts throughout the United States thought it very needful to have the National Water Model, and how it's developed in today's edition of the National Water Model. This video assumes that you have already gone through these explanations, read through, and done the short quizzes, so that you have a basis of what the National Water Model is. Today's video will focus in here on learning activity number 2, accessing the National Water Model through Python code. Alright, here is helping you to navigate and set up your Hydroshare account, as well as get ready to access the Jupyter Hub where our Python scripts are at. This video assumes that you have also already gone through this setup page and are ready to access the Python scripts. So we'll simply click on this link and come here to Hydroshare. I have already created an account. If you haven't done that, go back to Learning Module. The first step is actually at the very beginning of the National Water Model module. I'll show you right now. Come back up here to course, come here to instruction, module overview, and this step right here, before you continue, will help you set up an Hydroshare account. There's also a video going over that. But assuming that you've already done this, we'll come here to open with Quasi Jupyter Hub. And we are in. Now your screen might look slightly different depending on if you're in developer view or not. This is developer view. It's the same thing. Just make sure you click for this purposes of this activity. We're in the National Water Model Xarray notebook. The other videos are going over the National Water Model Notebook 1, 3, and 4. This is Notebook 2. Okay, here we are. We'll drag this over. We don't really need to look at that anymore. And we are in the National Water Model Notebook number 2, Mapping in Xarray. We're going to scroll right down here to the bottom to begin. And the purposes of this video is to go over and explain how to do exercise number 1. Exercise number 1 states, extract the river velocity values of a data array from the Xarray data set that we used earlier. What units are these values in? What reach ID corresponds with the largest velocity in the array? All right, if you feel confident or have an idea of how to go and do this, give it a try. If not, we're going to go over it right now. All right, we're going to scroll back up here to the top. And we are going to run through this code. Now, this video also assumes that you've read through the code, the explanations. There's really good explanations here. Some of this code might look a little scary, but I promise it's not that bad. If you read these short explanations just above each set of code block cells, I'm pretty confident that you'll be able to understand what exactly is happening. The nice thing here is that the code's already written for us. Mostly all we have to do is hit run. So as we know, code always starts from the top and we work towards the bottom. So the first cell is going to import all the packages we need. There's a lot of packages here. The one really important one is Xarray. That's actually what this exercise is all about. Xarray is just a package that's just going to organize all the data that comes from the National Water Model and kind of puts it into boxes for us. So we can categorize it by velocity, by stream flow, by all these different kinds of defining characteristics of each stream. And we can organize it from, say for example, this exercise, we want to know the largest velocity of a stream throughout the continental United States. So we're going to be able to sort all the streams from the highest flow rate to the lowest flow rate. So this comes out to be a very powerful tool for us. So we're going to hit run here. Perfect. If a number doesn't show up in the cell, that means it didn't run. So make sure you see a number show up. If you don't run these cells or don't hit run, your code's not going to work. Okay, so this big block of code, you might look very familiar if you've already gone through the National Water Model notebook number 1, titled Visualization. This code is basically going out and grabbing the data given from the National Water Model, grabbing its URL depending on what stream ID we put in, and then if we want a short range, medium range, or long range forecast, it goes through an if statement for that and sets it all up for us. Come down here, we're going to hit run here as well. For the purposes of this exercise, we're just going to do short range. Remember 1, this really isn't too important for us right now. Now this is the exact same thing as the first notebook. If you want to change this to medium range, feel free to do so. Long range, and you can change the member. All right. We're going to run this. This is simply going to open the National Water Model net CDF file as an Xarray data set. So there's lots of things we can see here. To answer one of the questions for this exercise, we can come in here to the velocity, which is what we're going after here, and we can click this little thing that says show/hide attributes. We're going to click it, and it's just going to tell us all these attributes of the velocity. So we got velocity, feature ID, long name, river velocity, units, and this is one of the questions for exercise number 1. The velocity that's given is in meters per second. So that's the answer there, meters per second. Gives coordinates, grid mapping, all these things. Going past this exercise, right? I mean, we could click on stream flow if you wanted. We could see the units that's given in meters cubed per second. It gives us all the basis of how our measurements are going to be taken. All right, continuing. We are going to come down here and run this cell. All right, it's setting up our arrays. It went through and grabbed all our URL with all the rivers actually throughout the continental United States. We know that there's 2.7 million reaches throughout the United States, and it's going through and it's grabbing all of those. So we're going to come down here, and now we're going to start organizing all of that data that we got. So this cell lets us separate out the variables of our data set into a dictionary or corresponding data array objects. This one right here is allowing us to separate our coordinates of data set into a dictionary of corresponding data array objects. Awesome. We'll keep coming down here, run this one as well. You can separate attributes of data set into a dictionary of corresponding data array objects. Perfect. We're honestly just going to keep hitting run here. This code's already written up for us. It's really not too bad. But make sure you stop on this step right here, because we are not looking to categorize by stream flow, but we are looking to categorize by velocity. Oh, if I could spell velocity. There we go. And now we're going to extract that stream flow velocity values from the data set as a data array. So we're going to hit run here again. And now you can see that's coming out, and we're going to have a bunch of velocity values, river velocity, meters per second. This is what we're looking for. This is very good. All right, let's come down here. And this cell right here, we're going to hit run again. We're now going to try sorting, replace streamflow for velocity values in descending order, and then dropping any null values. Now we can use this array is sorted from largest stream velocity value to smallest. So this is one of the questions to exercise number 1. What reach ID has the highest velocity? And we can see here that feature ID, okay, so this first reach ID is going to have our highest velocity, and the 14.22 meters per second is the highest velocity in the continental United States right now. Now this is going to get more clear as we move on, so let's hit run here as well. It says let's extract the largest flow, assign it into a value called largest flow, or in our case largest velocity. So you could come in here if you wanted to, and you could type in here largest velocity, but for the purpose of this video I'm just going to keep it the same. If you're trying to stay organized and use this in a bigger application, I'd highly suggest going and relabeling your variables for sure. But if you do that, you got to make sure you come through and change the rest of these. So this would be largest velocity as well, and so on and so forth. All right, so we're going to come down here and hit run here. Alrighty, so now we are going to convert it and put it in a pandas data frame. Now this is going to allow us to organize everything in a much clearer way. So we have all this organization going on, and we're going to hit run here as well. And before we hit run, we got to make sure, caught it before I hit run, sorry. We're going to put velocity instead of streamflow. Alrighty, hit run there. Boom, there we go. Now this is all looking a lot better, and this is our concise summary of everything that we were looking for. So this right here is the stream ID with the highest flow rate or velocity. So we can come in here and see it says velocity is 14.22. Well, that sounds very familiar. If we scroll back up here, we already said this number. See if I can find it again. Oh, it's here close. Yep, right here. When we ran this block of code right here, our first item or flow rate in this list, in this array, was 14.22 meters per second. So how awesome is that? This worked. The first reach ID was 227. Here 227-208-97. So this right here is the river in the continental United States right now that has the highest velocity or flow rate right now at 9:50 p.m. and this is the 3rd of May 2022. So when you do this exercise, obviously you're going to be doing this at a different day than I am, different time of year, flow rates are going to be different. So don't expect to get the same answers. Don't expect to get the same reach ID, because probably a different river somewhere else in the continental United States has a higher flow rate. That is it for now. Let's come down here and make sure we answered all the questions. Extract your river velocity values, a data array from Xarray dataset we used earlier. What units are these values in? Meters per second, right? What reach ID corresponds to the largest velocity in the array, and we figured that out. So that's it for this exercise. Hopefully that made sense, and stay tuned for exercise video tutorial for exercise number 2 coming up soon.